Hello everybody. Today's notes we're going to be talking about plate boundaries or plate tectonics. SWABAT. Students will be able to relate plate tectonics to the formation of different features of the crust or crustal features, and you should be able to describe how the plates can move in relationship to each other by the end of this video. So plate tectonics is a theory that comes from two different theories, the first one being the continental drift theory, which we just learned about. So Wegener's theory that the continents moved. And then later, the scientist Harry Hess discovered that magma was rising on the seafloor and it was causing it to move apart. And so he just had this discovery of seafloor spreading. And so those two theories make up the theory of plate tectonics. So after Harry Hess discovered what he discovered, everyone, or scientists said, oh my gosh, remember that Alfred Wegener guy, he had a theory that the continents moved. Maybe we should relook at his theory, and that's what happened. So we've got this theory of plate tectonics. So here's the theory. The theory is that the crust is divided into plates, and that those plates move over the asthenosphere. Remember that asthenosphere is like a putty-like, plastic-like upper part of the mantle, and so it can move a little bit. So those plates are moving because of convection in the mantle, which we've talked about, we're going to keep talking about. So convection is moving that asthenosphere. So here's a convection again. Convection is when hotter rock rises. Remember that the outer core is hotter than the mantle. So that outer core is heating up rocks. As it heats up, it rises because it becomes less dense. And then as it cools off near the crust, then it sinks back down. So we get this circular motion, and that is what moves the plates. So this is a little quick review. I'm going to quickly review this, and I'm not even going to say everything on these two slides, but these are notes that we took in Layers of the Earth. So the continental crust. The main thing I want you to know about this is that it's older and that it is less dense than oceanic crust. So oceanic crust is thinner, newer, and it's more dense, which is going to become important when these plates are interacting. So this is a review. Now, there are three different ways that plates can move, and there's a cute little song that you can sing that goes with it, and it goes along with the Addams Family theme song. So, converging is colliding, diverging is dividing, transform is sliding, we are the plate boundaries, da-na-na-na, 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 da-na-na-na. So if you have a hard time remembering what these different boundaries are, maybe you can come back to this song. So, we're going to first talk about divergent, or where plates are dividing or moving away from each other. So we're first going to talk about an oceanic plate and an oceanic plate diverging away from each other, so a divergent boundary. So when these two oceanic plates meet, so magma is coming up from the mantle, and it's pushing these two plates apart, and what happens is these plates form like mountains. New crust is coming up and creating mountains. So I know you would think there would be like this giant hole in the ocean, but it's actually a giant ridge of mountains. So an example is the Mid-Atlantic Ridge in the Atlantic Ocean. There's a divergent boundary that pretty much runs up the entire Atlantic Ocean, and we get this huge underwater mountain chain called the Mid-Atlantic Ridge. So this is also called seafloor spreading. So this is what Harry Hess discovered, and that's how plate tectonics was started. So new crust is being created because that magma comes up and then cools and becomes rock. And so that is brand new crust on the earth from magma. So that's a divergent boundary, oceanic, oceanic. We also can have a divergent boundary with two continental plates. And those two continental plates push apart. And we do have magma coming up. We can get volcanoes and stuff, but it kind of does create a valley. And in Africa, there is an example of this boundary, and it's called the Great Rift Valley. And this is a photograph of the Great Rift Valley. So we've got new crust being created again, and over time, water will fill in that valley. The next type of plate boundary is called a transform, where plates are sliding past each other. This causes earthquakes. Now, earthquakes can happen in other plate boundary types, but the main one that they occur out is at transform boundaries. We don't have crust being created or destroyed. It's just moving past each other. And it can happen in the ocean with oceanic crust, and it can happen on the continents with continental crust. And our example, which is what the photograph shows, is the San Andreas Fault in California. So this is a photograph of this fault. And so this is a plate boundary where there's crust sliding past each other. The last type of boundary is called convergent, where plates are moving towards each other. So the first type is continental-continental. So two continental plates hitting each other, and then when that happens, they push on each other and you get mountains. And our example is the Himalayas, which is where Mount Everest is. So we've got the Indian plate that moved and crashed into the Eurasian plate, and it created a chain of mountains where they have a colliding boundary right there. So those mountains are actually still getting bigger to this day because these two plates are colliding or have a convergent boundary. We can have an oceanic convergent boundary, so two oceanic plates hitting each other, and when that happens, the older of the crust subducts or goes underneath. So sub means below, like think submarine, below. So subducts meaning it goes underneath the other one. So in this case, we've got this side of the ocean crust going underneath this oceanic crust. And when that happens, the crust that's going under is getting destroyed. So it's melting into the mantle. And when that happens, we can have magma that comes up, and that can create a volcanic island. And it can create a whole chain of islands. And our example in this case is we've got Alaska here. And the Aleutian Islands are like this tail end of Alaska, which is where a convergent boundary is. So all these volcanoes are being formed at this convergent boundary. The final boundary that we can have is we can have a continental and an oceanic plate coming up against each other, converging, hitting each other. And when that happens, the oceanic plate goes underneath or subducts underneath the continental crust. And that happens because of density. The oceanic plate is more dense, and so it goes underneath. This creates volcanoes on the continent. So we have the same issue as the oceanic, where we've got this crust that's going down here is being like melted in the mantle, and magma can come up and create volcanoes. There's also a trench that forms, like kind of like this hole that happens. I don't want to say hole because it's not just a hole, but like if you dug a line in the dirt, that would be a trench. So it's where the one plate is going underneath the other one, and it kind of bends the other plate underneath a little bit. Our example, a real world example of this, is we've got the Cascade volcanoes in Washington, Oregon, and California, and that is where Mount St. Helens is, but there's this whole chain of volcanoes because we've got a plate boundary right kind of off the coast of Washington, Oregon, and California. So again, I want to ask the question, why does the oceanic plate subduct? And it comes down to density. We've got oceanic plates are denser, heavier for its weight or for its volume than continental plates. And so that makes it go underneath the continental plate. The Ring of Fire is a very active geological region in the world, and it surrounds the Pacific Ocean. So here's the Pacific Ocean. We've got all these different plate boundaries happening in this area. And that Ring of Fire is basically all these volcanoes. So all these little red stars are all active volcanoes in the world, and it's called the Ring of Fire. So there's lots of earthquakes here too, but all these plate boundaries are happening where we've got converging, diverging, and transform plate boundaries in this area of the Pacific Ocean. All right, some discussion questions. I am not going to go through all of these. I'm not going to read them, but I want you to look at them and see if you can make sure you've got your notes filled in and if you know how these movements work. So what are the movements for these different things? Can you show me with your hands? Are they converging? Are they separating? What do they look like? What does subduction mean? And then what do these different boundaries create? Do they create mountains? Do they create earthquakes? Do they create volcanoes? So all of these different plate boundaries create different things. So here's our meme for plate tectonics or plate boundaries, and always remember, science rocks.